recording now. Okay, great. Yeah, Smith though? All right. All right, who's got another question that they would like help with? Alex. 75, section 1.2. I love this one. I love this one. Number 75, section 1.2. All right, so what does section 1.2, number 75, what is that? Read the question for the class, Alex. All right, so let me make that do every 2. So here is 2, 1. Okay? And so they drew us a picture, right? I'm going to draw the line in green. It says stop in the first quadrant, right? Okay, so let's do this. Let me make my line green. So they want to know the area bounded by the line and the x and y axes. Okay. Now, I'm going to label a point here. I'll label this point. What is that point? What would you call it? First of all, do I want to give x a value? It can be anything, right? Maybe anything. But it can be multiple values, right? X could be here. It could be over here. It might even be able to be down here. So I don't want to give it a number value. I just want to give it an x value. And if I give it the value of x, what would the coordinates of that point be? What's that, Jeff? X comma 0. Good. Now, how many points have I labeled on that line? How many points? How you doing? Do I need to go louder? A little dance. You gonna be all right? I got 2 points. Can I find the slope as a function of x? In other words, if somebody gives me a value for x, could I find the slope? Yeah, I could do that, right? So let's find slope as a function of x. I'm going to do this in green as well. Slope as a function of x equals what? And every time I ask you, what is slope? Thank you. Thank you. Rise over run. And what is rise? Change in what? Change in y over the change in x. Okay. Now what does the change of y mean? Define change of y. Right, that's on this. And change in x is x2 minus x1. Okay. And I got 2 points. Which one do I want to be x1, y1, and which one do I want to be x2, y2? Jeff, you've been helpful. Which one do you want to be x1, y1? x0 is going to be x1, y1. Okay. So this equals, let's see, x right here, and that makes this 0 right here. And that means this is x2, y2, right? So x2 is my 2, and y2 is my 1. So do we see where I got my m as a function of x? Do we see that? I might skip a step here. Well, I didn't. I know where I'm going, but you don't. You don't. Who knows where I'm going right now? Okay. Let's take a step back and try and pull the curtain as to where I'm going here. What is the function, or let's go to the equation. What is the equation for the area of this triangle, Ben? Ben Nolan? Okay, 1/2 base times height. So area equals 1/2 base times height. Okay. Now, what is the base of that triangle, Violet? What's the base of this triangle? X. Okay. So, can I replace this B with an X? Okay. Let's do this. Let's make area a function of X. 1/2 X times H. Ooh. What about that H? Is that the Y? Well, when the X is here, Y is 0, right? Is that the Y I'm talking about? Which Y am I talking about? What do we call that? Y-intercept. Which, if I write out the equation for my line, is B. Unfortunate variable, right? So here's what I'm going to do. I am going to circle my y-intercept in red, and that is going to be, we're going to label that point. That is what point? 0, B. So now I gotta find my B. How do I find my B of a line? First thing I do is find my slope, right? And then I plug it back into the equation, right? So let's do that. Let's plug this back into our, I got my slope here. Let's simplify this. 1 minus 0 is 2 minus x. Well, I can't simplify that. So there's my function of slope, or my slope as a function of x. Equals that. Okay, so now, y equals 1 over 2 minus x times x plus b. And I'm putting it in different colors so we don't lose track. Okay, now, what point do you think I should put in for my x and my y? y21. y21. Why not x comma 0? Wouldn't help us, would it? But think about this. What is always common? What point is always on this mythical line that we're drawing? 2, 1 is always on this line. So that is the point I have to use. It's not that I have an option of using either this or this or this. I have to use that. Have to. Okay? So, when I do, I'm going to say 1 equals 1 over 2 minus x. Now, this x is not the same as this x. Right? This x is based on this guy. This x is my function. See where notation kind of bites us in the butt? But what is this x? When y equals 1, x equals 2. So, let's put that in there. And then, plus, I'm just going to leave it green for here on out. So now, I want to get b by itself. Let's simplify this term here first. So 1 equals what? 2 over 2 minus x plus b. How do I get b by itself? What's that, Will? Multiply 1 by the reciprocal of 1. So you want to multiply this by 2 minus x over 2. Okay, so how do I, if I do that, what do I have to multiply this by? And what do I have to multiply this by? If I multiply this whole side by 2 over 2 minus x, don't I have to multiply this whole thing by 2 minus, or 2 divided by 2 minus x? So this is going to get 2 divided by 2 minus x. We don't want to do that, do we? Subtract it. Subtract this. So I'm going to get 1 minus 2 over 2 minus x equals b. This is some hot garbage, so we're going to simplify this. We're going to simplify this by giving 1 a common denominator with this guy. So what do I multiply by? Does that give me a common denominator? Did I change the value of my expression? No. Okay. So then I get 2 minus 2. Oops. Hold on. 2 minus x minus 2 over 2 minus x equals b. You see how I got that? This basically becomes this, and then 2 minus x minus 2 on the top, and I keep the denominator. Can I simplify the numerator? Negative x over 2 minus x. Now, is that a function with respect to x? Yes, it is. So I can call this b of x right now, right? Now, this b is going to be that guy. That's my h, right? So now I got area with respect to x equals 1/2 x times b with respect to x. And that's how b with respect to x, right? It's that guy. So I just substitute that in. So then it's 1/2 x times negative x over 2 minus x. And then I simplify again. What does this simplify down to? Let's do it in steps. Let's not do it all at once. Simplify 1/2 x. X over 2. Times negative x over 2 minus x. And then how do I do that multiplication? Go with a simpler value. Let's do 1/2 times. What is that? What does that equal? 3/8. How do we get that? straight across, right? Equals 1 times 3 is 3 over 2 times 4, which is 8. If I can simplify, I can do that, right? I can either do it before or after. So if I had, let's see, 1/2 times 4 sevenths, I could simplify there, right? 4 and 2, oops, 4 and 2 share 2, so that becomes this. 1 times 2 is 2 over 7. I could do that too. Okay? So, when we multiply these, numerator times my numerator. So what do I get? Negative x squared over, not 2 times x minus 2, 2 times 2 minus x, or 4 minus 2x. And that is your area with respect to x. So now, what's the advantage of doing all that? I give you any x, and you can just plug and chug, right? You don't have to go through all that analytic geometry that we just did to come up with the formula, because now that we got the formula, we can just plug numbers in. Turn and burn. Not like that, but we can graph that. That'd be a pretty cool graph. Should we graph that? You want to graph that? All right. So, everybody, pull out your smartphones. And I want you to download an app called Desmos if you have not done so already. So, y a of x equals x squared divided by, and it was 4 minus 2x. No service, eh? That's disappointing. All right. So let's reset that. Check that out. Now, that's what the graph of this function looks like. But I got a question for you that we did not answer. Actually, the book had a question. What is the domain of this function? Let me ask you this. Just looking at this equation, or this function, rather, what number will not work in place of x? 2. Why 19? What equals 0 then? The denominator makes 0 if I put 2 in for x. Okay, now, looking at the graph, Tyson, why won't 2 work in that graph? Forget about the equation, just looking at the graph. I might be picking on you because you came in midway, right? You could. Check this out. If x equals 2, that point is right here, right? And if this point and that point are on the line, then I got that. And is that ever going to intersect? Is that ever going to intersect with the y-axis? No, right? No matter how far up it goes. So am I ever going to have a triangle bounded by this line and the x and y axis? No. Okay. Now, if you look at the graph, I took a quick glimpse of the graph. You see those values over here less than 2. I'm telling you that can't be. Why? Why can't I have values less than 2? You can't look at the equation now, you have to look at the graph. What's that? It has to be in the first quadrant, right? If I got a value of x right here, can I make a line between that and 2, 1? Absolutely I can. It's going to do that number. But where's the triangle? The line and the x and y axis, it creates the triangle in quadrant 4. So I'm not going to be able to use anything. I can't use 2. I can't use anything less than 2. So what is the domain of my function? Well, x equals 1 is a positive number, right? Has to be greater than 2, right? Has to be greater than 2. X has to be greater than 2. So my domain is x greater than. Like that? No. No. What's wrong with that? Can't equal 2. Bam. Okay? Now, why do I love these problems? Does this have geometry in it? Have you done geometry? Does this have lines in it? We've done lines, right? Does this have fractions in it? We've done fractions, right? Okay? Well, look at how everything, it ties together, right? And this is a really abstract problem. All I got is a Cartesian plane with a point and this hypothetical scenario. Hey, line crosses 0.21. That makes a triangle in the first quadrant with the x and y axis. Find the area. Find an equation that represents the area with respect to x. Do I care what y is in the? Do I care what this v is in this equation? I don't care. I do, but it's all encoded in here. I don't have to worry about it. I can just plug x in there and trust my algebra. That's the beautiful thing about this. That's modeling. Not modeling as in my skin's blotchy. I mean modeling as in I am modeling a situation with mathematics, with algebra. This is what you do in the world with math. Not on a Cartesian plane, but when you're surveying land to build a highway or to build a house. Right? This is what you do when you're plotting a course on a ship or on an airplane. This is what they do to not crash into Mars when they're trying to hit Saturn. This is what they're doing. Okay? So this is one of my favorite problems. Okay? And if we look at that graph, look at what happens to the area as x approaches 2. X approaches 2 is right here. See what happens to the area as x approaches 2 from this side. It shoots up to infinity. Right? Which should make sense to us. Because what does that, let's go back to, if this line is really close to 2, but just a little bit more, right? That triangle is going to be really tall. If it's really tall, it means it's going to have a lot of area. And the closer it gets to 2, the more that area is going to go up. Okay? What else do people have questions on? That's the jewel of section 2 and 3. That problem. Who's got another question? Does anybody want to do, I think it's 91 in section 3? Yeah, 91. So it's one of those use a graphing utility. If you get a question on the problem set asking you to use a graphing utility and you do not have a graphing calculator, use Desmos, okay? Use Desmos. It is a great tool to help you. Now, has anybody, when you use Desmos, you said the internet, the Wi-Fi is not working? Is that what you guys said? Is the Wi-Fi not working? Okay. So, there we go. All right. So I'm going to adjust the axes here because I can't see this right now. Let's see. That's X. So -1, 15, and this I'm going to make 1700, 1950. All right, and then I'm going to make this all right. So this is that function that they have in the book. If you put it in Desmos, you get this. All right. Now, what I put in here, let me. Come on. Okay, that's what I typed in there. Okay. This part right here is the equation that they gave me. Okay? This part right here is the domain that they gave me. So I can, if I took this out, if I took that stuff in the Whisker brackets out, the only thing that would change in Desmos is this side would continue on out infinitely, and this side would continue on out infinitely. Okay? So this just tells me how to limit my domain. Right? So when I look at that, I just punch it in just like I would if I was typing it on the computer. You can type it the same way in your smartphone. Okay? Now the question asks you on which intervals is population increasing in this function. So again, we're applying definitions, right? So where is population increasing? On what intervals? Function increasing right here. Looks like it's increasing to me, right? It reaches a peak right about here, and then it's all the way until, tell me when, right? And then it starts increasing again. So on what intervals is this function increasing? Increasing up to equal 0, right? And up to right there. So we'll call that t equals 5. So as long as t is less than 5, right? Whisker bracket. Is that the only place though? That's the only place. Where else? right here as well, right? You want to call that 11 or you want to call that 12? I'll take either one. Okay, so 12 less than t less than 14. So t is increasing. T is increasing on those two intervals. That's all it asks. That's all it asks. Oh, what is the maximum population between 1990, when t equals 0, and 2004, when t equals what? Look in your book. How does t change? During a 14-year period from 1990 to 2004, the population P in thousands of West Virginia fluctuated according to this model, where T represents the year, with T equals 0 corresponding to the year 1990. It's according to the U.S. Census Bureau. So what year between the years 1990 and 2004 does this population reach maximum? The maximum in 1990? How do I know this is at a maximum? What do you think, Barney? Guys, when is this graph at its highest? I'm sorry? Yeah, somewhere around 5, right? Here's the highest point right about there. I'm going to call it 5. What year does t equal 5 correlate to? 1995, right? So C would be T is at a maximum. I'm just abbreviating here. And then let's just read the graph to see. We can plug 5 into this equation, or we can just read the graph. And it asks us to estimate, right? So let's read the graph. Puts the population right there. 1800, 1810, 1820, 1830, 1840, 1850. So 1823. But that's not the population, right? It's thousands. So I have to add thousands on the end. So comma goes there, comma goes there. What's my population roughly in 1995? 1.8 million. People in West Virginia. We've heard graphs before, right? Don't get freaked out just because we're asking questions with the words domain and range and function in it. It's the same dang thing that you've done for 5, 6 years in math. No different. Just because I'm couching it with fancy words doesn't mean that you've forgotten how to do this stuff. But you need to engage your brain. are floating around in here? There's somebody getting flies in my classroom. Don't answer that. Don't answer that. But you need to engage your mind so that you can come to grasp with these definitions. If you don't know how to apply them critically, you're going to freak out every time you see the word function. And function comes up a lot in this class. Domain comes up a lot in this class. Range comes up a lot in this class. Okay? So, any other questions that were giving us problems in the practice set? Yeah, a few more minutes here. Not a lot. You got until Diddy. Yeah, we got until Diddy. Actually 45, so we got 8 more minutes. So, I don't want you to hand these in today. I'm moving the date that they're due to tomorrow, okay? Again, it's a practice set. So, who's feeling overburdened between this and all of their other classes? Okay, if you feel like you got a handle on this, okay, see if you can apply the definitions tomorrow on the quiz. Okay? Well, Mr. Cook, what happens if I don't do well on the quiz? You don't do well on the quiz. And then we find out what you're lacking, what you're missing, what knowledge you need to get beefed up for, what you need to get better at, and we hit it again. Is that the end of the world, y'all? Is it? I don't think it's the end of the world. We just have to do a little rework. I do rework all the time in the Navy. I fix a pump. And then, because you go underwater, right? You don't want your pump leaking seawater because that'd be a bad thing, right? So what do? Before you dive under the surface of the ocean, you test it, right? You put a bunch of pressure in there and see if it springs any leaks. Sometimes it would. You go, oh, snap. Gotta do it again. Yeah, you're upset because now you don't get to go home as early, but you're not going to die when you go out on the ocean, right? Same thing here. Do your practice, take the quiz. If you do well, great. If you don't, just fight another day. You're not on the ocean yet. You're only putting a pump up to it and applying some pressure. Okay? That's all you're doing. Did anybody else not turn in their quiz from the first section? So I'm missing a few. Those will, the ones that I don't have will show up as missing today. But you got them, hand them in. And then tomorrow will be the quiz. We'll take most of the class period to do the quizzes, but then we'll also take them home if you run out of time in class. Okay? So we'll be taking home quizzes. We can have class time to complete. Pretty nice on that. All right? Okay, cool. All right? If you're feeling rough about this, or just in general, most of y'all are juniors, right? Some of you seniors, some of you sophomores, most of you juniors. This is the hardest year of high school, isn't it? Seniors are kind of coasting because they can lighten up on their class load. Sophomores aren't they're not in it yet. And they're in it, but they don't know. But you juniors, it's tough. It's tough. But you get there. You all get there. Is everybody able to download Desmos? Am I talking too much? I'll shut up. You guys get some work time in. You may. These are the two dry sections of not the unit, but the course. These are the two dry sections of the course. It's all good. It's all good. We don't need to go higher up the flash. Well, the good thing about flies is they keep getting a chance. More of one physics class. I worked with oh, do you? When I worked at PowerPoint here, I worked in the summertime. I worked the overnight shift, and I was maintenance crew, so we were responsible for basically giving the store a good clean while there was a lot of customers in there, right? And one of the things that we had to do every day was we had to spray down the belly for insects. One day we got to do that, and it was 3-pound basket. Thanks. I take it, but I'll lose it, and then you'll have to do it again. So lift up the papers and it'll tell you. Thank you. But we forgot to spray it one day. And it was just like, you thought there was somebody's already opening. Yeah, where they can't be seen. Where they can't be seen.
I'm not here.
I don't know. No, we got all the way. Anybody talk to Lars today? That's the only thing it can be. But I want to bring it in for the very reason, if for no other reason, because I can't hold the lid on it.